So at Ammobia, we're trying to make a new story. We're working on Haber-Bosch 2.0. And Haber-Bosch 2.0 is a process designed to make ammonia from renewable energy. It can be any source of renewable energy. Solar power, wind power, geothermal, you name it, we can plug it in.
This is Bite Size Climate Tech, Season 2.
I'm very happy today because I got the CTO of Ammobia, Tristan Gilbert, with me. And he himself is a scientist. He has been working in this company called Ammonia. They started in 2023. And they have this great technology, Haber-Bosch 2.0. So I'm going to hand it over to him.
Thank you for having me. I'm excited to be here. I'm a co-founder and CTO of Ammobia. We're a seed stage startup. I started in 2023, and we're working on revolutionizing clean ammonia production. Ammonia today is one of the most mass-produced chemicals, largely as a fertilizer, essentially enabling the entire human population's growth since like the 1910s. The problem is that today all ammonia is made through what's called the Haber-Bosch process. And in this process, we react nitrogen and hydrogen at 500 degrees Celsius and 200 atmospheres of pressure. And the hydrogen comes from natural gas. So at Ammobia, we're trying to make a new story. We're working on Haber-Bosch 2.0. And Haber-Bosch 2.0 is a process designed to make ammonia from renewable energy. It can be any source of renewable energy. Solar power, wind power, geothermal, you name it, we can plug it in.
What is the reason that the 1.0 couldn't use renewable energy?
Well, because the process itself is operating in such harsh conditions, you have to build a plant that is massive for it to be economical. And at that plant size, the only energy available is from fossil fuels. Well, so our plants will be much smaller than the existing plants, anywhere from 10 times to 1,000 times smaller. And they will plug in directly to a renewable energy source, as well as take hydrogen from water and nitrogen from air. And we'll react all of that in our proprietary reactor, which runs at 200 degrees Celsius lower temperature than the Haber-Bosch process, and more notably, 100 times lower pressure. So our reactor is much cheaper, and it can run directly off of renewable energy.
Because it's much smaller, so then it makes sense and economical for you to use renewable energy. Anything that's more green than the natural gas. And I think last time you also mentioned there is a stat 95% of the ammonia. Like you also produce more ammonia.
That's
compared
right.
to the
Our process is much more efficient than other processes. Other processes, you typically make only around 20% of the ammonia you want at a time. And so you have to recycle your gases continuously, which is part of what makes the process so expensive. Our process is much more efficient. We convert upwards of 95% of our feedstocks to ammonia on the first try, so we don't need to recycle any of them.
I need to recycle at the beginning.
Oh, it's a great question. It's because your feedstocks are a very expensive component of the plant. So you're feeding in this high value hydrogen. And if you're only converting a fifth of that to ammonia, then you still have a ton of hydrogen coming out of the reactor. And you don't want to lose that hydrogen. So what they do today is they feed it back around. But it requires extra equipment, and that equipment has to function at high temperatures and high pressures, so it's expensive.
Yeah, because at the first attempt or any of the operation, you already get 95% of the ammonia. So you don't have to recycle the hydrogen, which means you're more efficient.
That's right, exactly.
Now I get it now.
How would you explain this to an 8-year-old?
Well, I would say that ammonia is very similar to food. In fact, as a fertilizer, it's used as a food for plants. But today, to make ammonia, you have to make it in a really expensive specialized oven. Very expensive oven, and it still makes bad food. With our process, now you can use a cheaper oven. So now more people can make ammonia. It's easier, and you still get a higher quality grade of ammonia. So you have better food coming out of this cheaper oven, and now you can use it for more things. So you can use it still as food for plants, but you can use it elsewhere. You can use it as food for cars, as food for ships, and it can be an energy source for a whole bunch of different applications.
It's a good analogy. The reason why in the previous version they can only be used as fertilizer is because that's the only thing that economically makes sense. And now because you have made it more like cheaper, so then it can be put into like cars as an energy source and some other stuff?
It's specifically that today ammonia is fairly cheap, but it's dirty. It comes from natural gas. So there's a ton of emissions made to make this. So
Okay.
if you go use that as a fuel in a ship, then it's more emitting than if you just burn the fossil fuel directly.
Okay.
So
In
for
your
it to make
process,
sense as a fuel, it needs to be a carbon-free ammonia. And our
okay.
process enables that carbon-free aspect.
But it also reminds me, because I'm a foodie, so if I sometimes go to like really expensive restaurants, like some restaurants just for the sake of being expensive, but the food is not good. Like
Yeah.
compared to like now, I mean, listen, some of the restaurants, they're like family run homemade food, but the quality is still good. Maybe that's also some similar
Yeah,
analogy there.
absolutely.
Okay.
I like that.
Yeah. Yeah, great. So, you have a question from a previous guest?
I mean, all the countries have different goals, very, very ambitious goals of, reaching net zero. Do you think this is possible? Do you think this is achievable?
Overall, I think that these net zero goals are achievable. Climate change is a call to humanity to change our ways, and that's something we're able to do. And we've seen many countries already start to have significant decreases in their emissions. The technology is really developing at a rapid pace. So I think these are achievable. I think we might need to change the timelines on certain of these goals, which we often see. People said they'd be net zero in 2030. Now it's 2040.
Yeah.
I think it's important to make a aspirational but achievable timeline to reach net zero, but I think it's absolutely achievable.
Yeah, I agree with you. Talking to people like yourself makes me realize I'm hopeful about the future. It's a matter of time and also how many people that we can inspire for them to come up with ideas and technologies like Ammobia to make these goals achievable. Now it's exciting time that you can leave a question for the next one.
I would ask a next guest what policy changes they would like to see to support the growth of their product in particular.
Interesting. Just out of curiosity, what policy changes you would like to see for your product?
I would like to see either an incentive or a tax, the opposite, to use clean fuels in the maritime shipping industry.
Is that exist nowadays?
No, not most places, at least. Not in America.
It will come hopefully at some point. Oh, thank you so much, Tristan. It's a pleasure having you on the show.
Thanks for having me. This was really fun.
Express my guests are their own and do not necessarily reflect the official position of iSize Climate Tech. We thank our guests for sharing their insights and experiences, and we thank you, our listeners, for joining us on this journey. Until next time.